Now, what we're going to find is that when these elements combine, they are going to create a bond. One of the types of bonds is covalent, where they share their electrons, like the carbon and the hydrogen right here. They're sharing the electrons equally around each element. When we have a sharing where we've got two elements, like the carbon and the hydrogen, and they're sharing only one pair, it would be a single covalent. If they're sharing 4 electrons, that's double. This is meaning how many bonds could be between the two elements. So if there's only, like if I've got an element here and an element here, and there's only one, like electron, electron, that's it. That's single. If there's an electron, 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 bond, bond, that's double. If it is going to be the electrons being shared equally, so let's go over here and take a peek at my carbon and my hydrogen. For my carbon and my hydrogen, they are sharing those electrons equally all the way around. Nobody has more electrons at this point versus that point. If the electrons are not shared equally, it is going to be polar covalent. Now, what does that mean, being polar covalent? Well, let's take a peek. Let me see if I have, I don't. Okay, let's take a peek at something very important that has a polar covalent bond. Ever seen that? What is it? Water. The most important substance on the face of the planet. Life cannot exist without water. Water is the only substance on the planet that can exist in all 3 states: a solid, a liquid, and a gas. When you look at the structure of water, all right, let's think for a second here. Oxygen is number 8 on the periodic table. Hydrogen is number 1. So if I've got my oxygen and it has 8 electrons, so in the first shell 2, and the outer shell 6. Not happy. But then along here comes hydrogen with its 1 little electron, and they go, oh, yay! And they now are sharing electrons. Hydrogen only needs 1. Oxygen needs 8. Because of that, the structure of water looks like, usually represented like this, where this is oxygen, hydrogen, hydrogen. Looks like an upside down Mickey Mouse. But the electrons are not being shared equally in either bond. Therefore, not sharing equally is making water be a polar covalent bond. Now, polar covalent is telling me that because this structure is what it is, there is more negativity around my oxygen and less around my hydrogen. So that makes my hydrogen a little positive, oxygen a little negative. So I now have some negative and some positive on my water molecule. All right, where this is a little negative, this is a little positive. And then if I have another water molecule and another one, all right, where all of them have some negative and some positive, opposites what? Only in chemistry. So what does that tell me? That tells me that the negative would attract to the positive. Because water molecules do this, it makes water one of the most important substances. It is the most important substances on the face of the planet. It gives water very unique properties. Now, I said it can exist in 3 states, solid, liquid, gas. But properties of water: cohesive. What does it mean to be cohesive? It's attraction to other molecules. And what about adhesive? Adhesive means to do what? Stick together. Why am I kind of emphasizing this? The human body is what percentage water? Depending on weight, okay, anywhere from 60 to 90. 90 is going to be a baby, okay? What percentage of your blood is water? Roughly 75%. And the blood has to do 2 things. Well, it has to do a lot, but because of water, blood is cohesive and adhesive. Guess what else water can do in the body? All these bonds, they get formed in the body. For example, if we take in a salt, sodium chloride gets into the body, it's in a water environment, salt will break down. I now have sodium ions, chlorine ions in my body, along with all the others that you have in salt. It's not just sodium and chlorine. It's magnesium, potassium, zinc, all the other ones too, okay? And then I have to, in my cells, build bonds, and water will be given off. Water is the substance of life. Any of y'all watch The Walking Dead? Or The Fear of the Walking Dead? Any of that? Okay. Well, you know, I'm done with my Walking Dead. Okay. Then I was like, Fear of the Walking Dead? What's Fear of the Walking Dead? So, you know, I read a little information on it, and I'm like, oh, it's supposed to tell me how we got to The Walking Dead. Hadn't told me a whole lot. But anyway, I'm at this season with the episodes where the guy has all the water, all right, you know, and he's got a whole bunch of, there's a whole river right there behind it, okay, and everybody's like wanting the water because they don't have it. Really cool, because we gotta have water. Without it, we're gonna die. So water is a polar covalent bond, and because of the structure that gets formed, gives it extremely unique properties. And they are really, I guess you could say, they are really going to be life-sustaining, life-giving properties. So when we look at the ions that are going to be in the body, like I just said, when we take in salts, they're going to create ions. Because when we take in the salts, the foodstuffs, and we break them down, and we get these components from it, we're going to find some of them have negative and positive charges. What is another way that we are told, or another name, we're told these are called? Well, if we're talking about like taking in foodstuffs, and that includes waters and drinks and stuff that we take in, when we take them in and we break these salts down, okay, these foodstuffs down, and we get these positive and negatively charged particles, do you know of another name that they might be called?
Nutrients.
Electrolytes. Ah, hold up. Sodiums, potassiums, calciums, phosphates, irons, magnesiums. What do you see beside every single thing right here? You see a charge. In some way, it's going to react in the body. The ones that we know of as electrolytes, what does that term make you think of? Well, the sports drinks are one way that it's kind of like, you know, the PR for it, okay? Replacing the electrolytes, electricity
For cells.
for
Cells.
muscles, nerves, because this is how we're going to generate their activity. It's going to all be based on the pluses and the negatives, which is kind of cool, just say. So, let's stop right here at this point, and let's look at Lab 1 for today. Okay, in Lab 1, okay, so one of the things about the U.S., all right, we are the only country that does not use the metric system. You happen to know why? We're the only country. And it really is very easy. It is the easiest system of measurement. It's different. But the reason that we don't use the metric system is because back in the 70s, now this was when I was in school, I actually remember this. This is when they expected teachers